This cycle is collectively known as the limestone reaction cycle. That is because calcium carbonate is the major component of limestone. Now that can form calcium oxide, which is sometimes known as quicklime, and calcium oxide can then form calcium hydroxide, which is down here, and that is sometimes known as slaked lime. Now slaked lime is a solid, but it can be dissolved into solution, and we call this solution lime water, which I'm sure you've heard of. And from lime water, we can add carbon dioxide and we can get back to our original calcium carbonate, which is part of limestone. Now, if you've watched my previous video on equations, one thing which I hope you're confused about is where does the carbon go? How do we get from calcium carbonate to calcium oxide? And we haven't shown any other sort of reaction. It is important to realise that these sorts of diagrams are there as a simplification. They do not show the whole reaction. For example, going from calcium carbonate to calcium oxide, we actually lose carbon dioxide, CO2. That is a thermal decomposition. And then it makes sense that to get our carbon back, to reform calcium carbonate, we have to add CO2. Okay, or we add CO2 there. But then how about obtaining the hydrogen in slaked lime from quicklime? Well, that comes from adding water. We add water at this stage. We add our extra oxygens and our hydrogens. Now it's important here to realise that we're making a solid in slaked lime, and so we only add a tiny amount of water, enough to make the solid, but not so that we've got any left over, because then that would form a solution. And that's exactly what we're going to do next. So here we're adding more water. Now that's not going to cause it to react in any different way. This is actually in a way diluting. And so we'll have leftover water. And so this is now a solution rather than being a solid. So all we're doing really is dissolving our solid into a solution, and we call that solution lime water. And one last thing, we also filter this solution, and that is to get rid of any excess solid that we don't want. So a filter obviously is not a chemical, but it is a condition. So if you're asked, what are the conditions for this reaction? How do we form lime water? Well, we form slaked lime and then we dissolve it in water and filter it. Now let's take a look at the important reactions separately, just so you get a better idea, because this is quite a lot of information on one page. So if we start with our calcium carbonate, the first reaction in order to obtain calcium oxide is called a thermal decomposition. So thermal decomposition, which literally means breaking down using heat. And so we're breaking down the calcium carbonate into smaller chunks, which are calcium oxide and carbon dioxide. Now this is a very important reaction in chemistry, because it's not only calcium carbonate that will react in this way. In fact, we find that many metals actually undergo the same kind of reaction. For example, if we have a look at this periodic table, we can see that here, calcium is in group 2. It's in the group 2 metals. Now, it turns out every single metal in this group will react in this same way. And so the carbonates of all of these metals will react in the same way. For example, magnesium carbonate will react in the same way and form magnesium oxide and CO2. So this reaction is identical, and all we've done is we've swapped the calcium for the magnesium. We can say that this is by heating as well. And so you could be given many different metals and asked to write the equation for the thermal decomposition, and this is exactly what they'd look like. Two metals which will not decompose under normal heating that we can do in a lab are sodium and potassium. So if you remember, sodium and potassium carbonates under a Bunsen burner flame, so how we would normally heat them in a lab, they will not decompose, but calcium carbonate will, magnesium carbonate will, and many other metals will also react. Okay, so let's have a look at our product, calcium oxide, which we produce. Calcium oxide can be referred to as quicklime, and it is the next stage in our cycle which we are going to use to produce calcium hydroxide. So as I mentioned earlier, calcium oxide added to water, a small amount of water in this case, will give us calcium hydroxide as a solid. Now the calcium hydroxide is soluble in water. However, it is not very soluble, so we need to add quite a lot of water to it to get it to dissolve. Normally we will still have some solid calcium hydroxide left over. So let's just say calcium hydroxide in water will form a calcium hydroxide solution, which we call lime water. Now you'll notice here that I've put the water above the arrow. I haven't included it in the equation. That is because in this case we are not forming a new substance. Calcium hydroxide in solid and calcium hydroxide in solution is still calcium hydroxide. So a chemical reaction isn't happening here. What we are doing is we are dissolving the calcium hydroxide solid. And so the water not taking part in the reaction doesn't have to be written in the chemical reaction. Remember, above the arrow, just like with heat in our previous equation here, just like the heat here, the water, in this case, actually shows you that that is a condition rather than part of the reaction. Okay, so now only one more step to go, and that is turning lime water back into calcium carbonate. So here we have our lime water, and we bubble in CO2, carbon dioxide. That then reacts to form calcium carbonate, which is what we started with, part of limestone, and then it gives us our water back. Remember, we added water to form calcium hydroxide, and as this is a cycle, we must get that water back. And here is the step where we get the water given back out. An important thing to note here is this is actually the test for carbon dioxide. If we have a substance or a mixture of a gas, and we want to see whether we have CO2 in there, we can take some lime water, so calcium hydroxide solution, and we can bubble the gas through it. Now, if CO2 is contained in our gas, then we will form calcium carbonate. And the way that we can see that visually, if we're in the lab, is that our solution will turn milky or cloudy. Now, we've now covered all the reactions which you saw in the original cycle. We started with our thermal decomposition, which forms calcium oxide from calcium carbonate. Calcium oxide, we then add a small amount of water, and we will get slaked lime or calcium hydroxide. We then dissolve calcium hydroxide so that we get a solution known as lime water. And we can then test for CO2 or just add CO2, bubble it through, and we will reform calcium carbonate. Now, one question you might be asking yourself is, why is it useful to learn about these things? Why do these chemicals really matter to us? And they do have many uses, and I'll go through a few of them now. Now, you might have heard of a substance called mortar, which is used a lot in construction, in building houses. Now, mortar is used to hold bricks or building blocks together, and this is actually made from calcium hydroxide. So calcium hydroxide, and you add water and sand, will give you mortar. Now, the reason this works goes back to the equation that we just went through. So calcium hydroxide plus CO2 will give us calcium carbonate, which is the main component of limestone, which is of course a rock, and it's hard and it will hold things together. Now, when the blocks are put together using the mortar, they are left outside to dry, and the air contains carbon dioxide, and so calcium hydroxide plus the carbon dioxide will turn it into calcium carbonate. So in effect, it's almost like holding the blocks together by making rock from the calcium hydroxide. Another very useful substance, which I'm sure you've heard of, is cement. Now, cement is made up of limestone, which is of course primarily made of calcium carbonate. Now, the limestone is added to clay, and it is then heated in something called a kiln. This causes a reaction to occur, and the product is the powder that we call cement. And it's important that we break this down into powder, and that is how we use it, because then when we come to use the cement, we add the water when we need it. Sand is also added very often as well. Now, other types of cement have been made as well by adding different minerals which can affect the properties of the cement, and this varies around the world, but one main type is called Portland cement. Now, one last important building material is concrete. Concrete. Now, this often gets mixed with cement. People confuse the two. It's important to note that concrete is made using cement. So we create cement first, and then we create concrete from the cement. We do this by adding sand, so cement plus sand, and then we add small crushed rocks, which we collectively call aggregate. Aggregate. Now, the mixture of these substances provides especially strong resistance to crushing forces and forces which would squash it or damage it in that way. And this is what makes concrete blocks so strong and very hard to destroy. Now, finally, we can also reinforce the concrete by allowing it to set around steel rods. So steel is a very strong metal, and this will allow the concrete to resist forces which would stretch it. So concrete on its own is very resistant to squashing and crushing forces, but the opposite to that is a stretching force. And reinforcing the concrete with these steel rods provides resistance to that kind of force as well. So for reinforced concrete, we also have steel rods. So the last thing I want to mention is that all of these substances, so calcium carbonate, calcium oxide, and calcium hydroxide, all of those substances have a pH which is above 7. They are all considered alkali or basic in character. And this means that they can neutralize acidic substances. So they will neutralize an acid. Now, the most basic of these, or the most alkali of these, is the calcium hydroxide, so slaked lime. Now, if we put calcium hydroxide into soil, it is very good at counteracting acidic substances which can be naturally found in soil. So very useful for farmers. Farmers can add this to their soil, creates better quality soil because the soil is now more neutral. It's become less acidic, which is kinder, if you like, to the plants which are looking to grow. If a soil becomes too acidic, then it becomes a very harsh environment and it can end up with crops dying or not growing as they should do. Now that's about all I want to go through in this video. I hope that's helped clear up the differences between these substances, and also that you don't have to just learn this cycle. You really want to understand each stage of the cycle, and it means that remembering the cycle is easy. If you don't remember each stage and each reaction separately, it means that you could get the stages confused. So now that you understand the stages, it should be easy to remember the cycle. Now, any questions you may have, please put them in the comments below, and I look forward to seeing you in the next video.